So on the left here, make this a little bigger. Both of them are at y equals already. So I don't have to solve anything because we have y equals y equals. When you get a situation like this, you literally can take either the x minus 1 and substitute it in, or the 2x plus 7 and substitute it in. So what you're going to get is just the one equation equals the other equation. So 2x plus 7 equals x minus 1. Now we solve for x. So I'm going to take away x. X plus 7 is negative 1 minus 7. So x is, again, negative 8. So part of our answer we know is going to have negative 8. Now I can substitute this negative 8 in for either of these. To me, it makes a little more sense to substitute it into the bottom one. So then I'm going to have y equals whatever x is, which in this case is negative 8 minus 1. So y turns out to be negative 9. Now, could we have graphed this in order to figure out that this was a solution? Yes. But you also can use substitution since they both are already down to one of the variables in order to just solve it. All right, let's try this one. Oh, and an essential thing is to go back and just check your work. So if I went back and looked at this, y is negative 9 and x is negative 8. And I need to check it for both of my equations just to make sure. So does the right side end up being negative 9? All right, so we have negative 16, and negative 16 plus 7 is, in fact, negative 9. Then we have negative 9 is negative 8, take away 1. In this case, yes, it's easier because you already have this. And this, in fact, does equal the same. So you want to make sure just that your coordinate point does work for both the equations. All right, with this one, neither equation is solved for the x or the y. So you look and decide, well, which one makes more sense to start with? Well, I have 3y, 4x, negative 2x, and just a y. I am going to solve for this y. So I'm going to bring over that negative 2x. Opposite of a negative is a positive. So now I have y equals negative 3 plus 2x. I'm going to take this value and plug it in to the 3y. So now I have 3 times what y equals. Y equals this whole thing. So negative 3 plus 2x. And then I still have plus 4x equals 14. So with this, I need to distribute out. So 3 times negative 3 is negative 9. 3 times 2x is 6x. And we have plus 4x is 14. All right, so now combine. So negative 9 plus 10x is 14. Add 9. So 10x is 23. Divide by 10. And x equals 2.3. And yes, you will be getting decimals and fractions, which is why it comes down to substituting and eliminating are going to be the best bets for those, because it's harder to get a decimal or fraction when you graph. All right, so x is 2.3. I'm now going to put that value in to one of the equations. To me, makes more sense to put it in the second one. So negative 2 times 2.3 plus y equals negative 3. So this is negative 4.6 plus y is negative 3. Add 4.6. and y equals 1.6. So my answer is 2.3, 1.6. And you do have to put, your final answer into a coordinate point. If you leave it as x is 2.3, y is 1.6, it does not give you your full answer. Your full answer is a coordinate point. Let's try it again now, but I'm showing you how you get infinitely many or no solutions. And substitution is going to be one of the methods I think that we practice the most because the substituting piece I think can be the hardest. All right, so I have this where it's x equals. So I'm going to take all of this and put it into there. So 3.5 times negative 2y plus 4 plus 7y, I gotta remember the rest of it, is 14. All right, I'm going to multiply out 3.5 times negative 2. Well, positive times the negative is a negative, and 3.5 doubled is 7. So negative 7y. And then I have 3.45 times 4. So 3 times 4 is 12. Half of 12 is 4. So we get, half of 4 is 2, so 14. And then plus 7y equals 14. Now look what happens. 7y and 7y cancel because negative 7 plus 7 is 0. And I'm left with 14 equals 14. Is that a true statement? Yes, it is. So this is infinitely many solutions. When it comes down to where it is a true statement, it is infinitely many, meaning these two are actually the same line. So when I look at this one, I, again, have it to where y is simplified down. So I'm going to take this and put it into that. So instead of y, I'm going to put 3x minus 11. And then I still have minus 3x is negative 13. So again, the same thing that we just did. 3x, take away 3x. That cancels. And I'm left with negative 11 equals negative 13. Is that a true statement? It is not. So this is a no solution. So if it comes down to be a true statement, infinitely many, no true statement, or not a true statement, no solution. All right, we have learned graphing and substitution. Now we are going to work with elimination. Elimination is just what it sounds like. You are eliminating something. So if you can easily cancel out the x or the y without doing, a whole bunch of stuff, elimination is pretty easy. When I look at this, 2x and 6x, well, I can't cancel them out. I know there is something I could do. I could multiply the 2 by negative 3 in order to make it opposite. Because what your goal is you're making the x's opposite or the y's. But look at this right here. Are my y's opposite? Adding 5, subtracting 5. Are they opposite of each other? They are. This can cancel. It can eliminate. And I'm doing it by adding because 5 plus negative 5 is 0. So I'm going to add the rest of them. 2 plus 6 is 8x. That canceled. That was my goal. Equals negative 17 plus, 17 plus negative 9 is 8. So now I just solve for x. So I get x equals 1. So I was able to eliminate my y's, solve for x. Now I take this x and put it back into either equation to solve for y. So I'll do it for the first one. 2 times x, which is 1, plus 5y is 17. So this is 2, so I'm going to take away 2. So 5y is 15. So y is 3. Now remember, I do not leave that as my answer. I have to put it as a coordinate point. 1, 3. And that is my answer. When I go back and check, 1, 3. So 2 times, or 2 plus 15 is 17. Yes. 6, take away 15 is negative 9. Yes. So this is my answer. Now we're going to try it with subtracting, because can I eliminate the y's? 4 take away 2. Nope, still have 2y. Can I eliminate my 2's or my x's? 2 plus 2 is 4. No, but I can subtract. So if I subtract the bottom, this is what happens. Everything turns opposite. So I'm left with 2x plus 4y is 22 on the top. And when I subtract the bottom, I take away 2x. I take away a negative. When you take away a negative, you're really adding. And I'm taking away another negative, which means again that I'm adding. Well, now I can cancel out my x's. This eliminates. 4 plus 2 is 6y. And 22 plus 8 is 30. So I divide out, and I get y equals 5. So again, because I was not able to just eliminate because they aren't opposite, I need to make one of the x's opposite. So I made the whole bottom row opposite. If you make the x, you have to make the y and the constant. So I subtracted. Taking away a 2x, subtract. Taking away a negative, add. Taking away a negative, add. So that's how I get to this. Now, like we've been doing, we take our y value and plug it back in. Now, if I use the bottom, I use the original equation. I'm just going to use the top. So 2x plus 4 times y, which is 5, is 22. So 2x is 20, or plus 20. So I'm going to take away 20 here. So 2x is left with 2. X equals 1. So let's really quickly check. 2 times 1 is 2. 4 times 5 is 5. 4 times 5 is 20. 2 plus 20 is 22. Good. 2 times 1 is 2. 2 times 5 is 10. 2 take away 10 is negative 8. Correct. So our final answer is 1, 5. That is where these two equations intersect on a graph. Now, sometimes you can eliminate by making one or the other equation a little bit bigger. So I'm only going to multiply one of the equations to make them opposite. Can I make 7 opposite of negative 2? Yeah, I mean, I could, but I have to do something to both equations. But can I make negative 5 opposite of 15? I can, by multiplying this to 3. Because watch what happens. If I multiply each piece, I still have negative 2x plus 15y is negative 32 on top. And then when I multiply this out, I get 21x. Take away 15y. Well, what do you notice about the y's? Can we eliminate these? Yes. And then equals 51. So I can eliminate my y's because 15 take away 15 is 0. Poof, gone. Now let's add the rest. Negative 2 plus 21 is 19. So I have 19x equals, should know this, but, 19. 19. So what does x give us? 1. All right, let's plug that into, let's do the top one again. Negative 2 times 1 plus 15y is negative 32. All right, this is a negative 2. So in order to get rid of that, I'm going to add 2 on this side. I'm left with